when you want me to kick it off.
All right, we're good. Please.
All right. Dion Gordon, Tech Birmingham. This is Navigating the New Normal. And I am navigating first world technology because my AirPods are not working. So you roll with the punches and you adapt. And I think that is very apropos given the title of this series and what everybody is facing. We are adapting. We are rolling with the punches. We are recognizing when things are not working or when they can work better. And so I think that we have an opportunity to really pull on that thread and explore some interesting concepts and topics around that very idea regarding AI, how AI learns, how we can learn better. What are some of the lessons that can be pulled and applied as we try to better ourselves, as we try to adapt? And so I definitely won't steal the thunder. The individuals that we have joining us are a lot more qualified, a lot more handsome than I am. So I think you will enjoy hearing them talk about it a little bit more than hearing me go on, but you all are definitely in for a treat. I also want to let you all know that you should be members of Tech Birmingham. Make sure we get that out of the way, because as we all adapt and navigate, that takes a lot of resources, a lot of manpower. And we need people to lean in and to help us do this work, to do this work collectively as a community. I have been encouraged by the resiliency of not just our ecosystem, but Birmingham at large. And so I think this is a unique opportunity for Birmingham to really survive and thrive in these crazy times. And your support allows us in so many ways to lean into that work, to push forward with that vision. So make sure you are a member, techbirmingham.com. And as always, we will be uploading the recordings of these sessions on our YouTube channel. And that is youtube.com/techbham. I will give a shout out to Matt Cowell because not only is he handsome, but he happens to be, first world problems. All right, Siri is going off. I guess she did not like the fact that I was talking about Matt Cowell and how he's a wonderful board member. You can take it up with Siri, Matt. I had nothing to do with that, but I want to say thanks. And of course, he's going to be joined by Nathan. And while we're giving shout outs and recognition, I do want to say thanks to you all for tuning in, whether you are live with us or if you happen to catch this via recording, you're still spending time with us. And so we want to acknowledge that and say thanks. And I also have to give a wonderful, heartfelt shout out to the team over at Tech Birmingham, Christina Smith, Rebecca Dobrinsky. You guys already know they cover my sins, and they are the glue that keeps all of this together. I've talked long enough. Thank you all again. Christina, if maybe a couple of seconds, you would like to go over any housekeeping items or polish up something that I might have messed up, that'd be great. And then we'll turn it over to our friends at QuantHub.
No, that's great. So just like our normal format, if you have questions for Matt and Nathan, go ahead and drop it in either the chat box or the Q&A. Dion and I will be monitoring those, and we will reserve some time at the end to get all of those questions answered. So with that, I'm done. Thank you.
Fantastic. Thank you, Christina. All right. The moment we all have been waiting for. We have Matt and Nathan here to talk to us about AI, how AI learns, and what we can learn. That's a lot of learning, isn't it? What we can learn about the process and how we can become better at it and retain more information as well. So with that said, gentlemen, thanks again. The floor is all yours.
Okay. All right. Thanks, Dion. Thanks, Christina. Thanks, Rebecca, as well. And so we're excited to talk about this today. This is a topic that's sort of near and dear to our hearts at QuantHub. Is really the way we learn as humans. And so at QuantHub, that's a big part of what we do. And there have been so many advances in AI, and I mean, AI has become such a buzzword, but there's so much real science behind what's going on with AI, and there's something there for us to learn as well in terms of how we can learn better as actual individuals. And so my name is Matt Cowell. I'm the CEO at QuantHub, and then Nathan Black is on as well. Nathan is our chief data scientist at QuantHub, and so basically my role today is just to facilitate getting through the content and letting Nathan shine and actually talk about what he knows, because I really don't understand this either. So Nathan's the brainchild, and I'm just the slide clicker. And so just a little bit about us to kind of set a frame of reference here. So at QuantHub, we exist to help and empower organizations to build a high degree of data fluency across their entire team. And so we started this journey. We're a startup here in Birmingham, and we started this journey as an offshoot of a company called StrategyWise in town. And we really started with an assessment platform on data skills, and to help organizations and individuals, help organizations that are hiring figure out who has the skills to do the job and who doesn't. And so all built on the premises that if you want to do artificial intelligence, you want to get value out of your data, you can't do so without actually having a great team in place. You have to have a great team, a highly competent team of people that understand data engineering, that understand data science. But as we got further into this, what we really discovered is that it's not enough to help organizations hire well. We have to also help organizations upskill and reskill and get people into this field, because there's a tremendous shortage of data talent in the world. It's a global shortage, a massive shortage. And so without upskilling or reskilling, people within organizations are ready to be more fluent from a data perspective, we're just not going to solve this big talent gap. And so that's actually a big part of where we've come on our journey in about 2.5 years as a startup. This is our mission statement, is to be a catalyst for the data fluency of organizations and individuals all over the world. And so to really do that, now our platform helps companies hire. So we have an assessment platform on all things data. And so it helps companies hire, but also those same types of assessments are very useful. And we'll talk about this today. The science behind it are very useful in upskilling or training, if you will, individuals. And so we really comprehensively focus on helping organizations build great data skills. And the reason we're here talking to you today is that sort of led us down a journey, and Nathan in particular, around really understanding the science behind learning. How is it that that humans learn most effectively? What does cognitive psychology tell us? And there are some really, really interesting parallels between how humans learn most effectively and actually the advances in machine learning. Nathan, why don't you talk briefly kind of about the history here? I mean, when did we sort of discover the most effective way for humans to learn, and when did machine learning and kind of AI sort of come along?
Yeah, so human learning has been around for since humans have, but really the research started to boom around the 1940s when people started studying the most efficient ways to learn. Usually that was for the to upskill a workforce. How do we provide efficient training, and then also a lot into education programs. So a lot of research started popping up around the best practices in cognitive psychology, and how do we manage what we learn and manage our memory, and then that was followed up about a decade later in the 1950s, when people started trying to figure out how do we teach a computer to emulate what humans do? How do we train a computer to solve certain tasks like a human does. And so they borrowed a lot from cognitive psychology, and it really was the birth of cognitive science, which is just the parallel of cognitive psychology that focuses on the computer side.
Yeah. What's interesting is that research has been around so long in terms of how humans learn so effectively, or how humans learn most effectively. But what's really interesting about that is we don't apply a lot of those practices in our educational systems, whether that's in an academic setting or even in training programs and the way we tend to teach people that we work with. And so what we're going to talk about today is a few corollaries between how humans tend to approach learning, even 80 years after these concepts were introduced, how we still tend to approach learning in effective ways. And then we're actually going to draw the comparisons or the parallels between how machines approach that in AI, and draw some parallels there on how we can actually rethink learning as humans and be more effective. And so just jumping right in, the first one is actually the concept of testing. And so, I'm actually going to play the role of the humans that don't learn very effectively, and then Nathan's going to play the role of the machines that learn very effectively. So if you're like me, you think of tests, and this is a stressful thing, right? So you're thinking of, I'm going to take this test. I'm stressed out. It's a stressful thing, and I don't necessarily enjoy taking tests. But beyond that, a lot of, if you think back to like school, when you were learning in school, a lot of what you're doing and a lot of what we tend to do is we will learn in order to take that test. And so we will cram. Like for me in college, I took a lot of my, I probably crammed a little more than I would like to admit. I took most of my final exams on no sleep, and I would stay up the entire night before and cram all this information in my brain. I did really well, but I don't remember any of that stuff. And so there are reasons that Nathan will talk about probably that are there are causes for me not remembering that stuff. But that's typical, though, of the way we tend to learn. We think of learning, we think of testing as something that we learn for a long time and then we'll test. And so we're learning really just to be tested, and which is not necessarily the best way to do it. And so Nathan, talk a little bit about forward pass.
Yeah. So following on what Matt was saying, that a lot of that anxiety is built up because there's the assumption of knowledge whenever you take a test, that it's testing what you know. So the kind of the flip side of how machines approach this is they take testing as a technique for learning, and actually do a test first approach. And the way that's done, you're looking at a neural network here. So in deep learning, there's this concept of a forward pass, where you just take your inputs and you feed them through all of these combinations of weights and activation functions, and produce an output, and check that against something that you already know. You check that against the correct answer. So you can imagine it like a teacher saying, here's a test, take the test, see if what you get correct. The difference is that those weights that represent the learning that a deep learning model does, is they're initialized randomly, which means that it assumes no knowledge before it starts, and it just gives it a try. It says, hey, I'm just gonna make my best guess right now. Starts with a test, and that starts the feedback loop of test, figure out where your skill gaps are, and it allows you to free up your view of testing, to where it's not it shifts it from being a tool to judge you to a tool that is used to learn.
Right, right. And so the key takeaway here back to for humans like me that need to learn better and more effectively is really test early and often. And so like Nathan said, incorporate tests into as a mechanism for learning, not just as a mechanism to Nathan's point of evaluating. So almost like a test-driven learning approach, if you will. The next area is really the concept of retrospection. And so oftentimes when we finish something, we focus very much on whether we got things right or wrong. And so we focus on our successes and strengths. I finished this thing, I got it right, and I'm moving on, and that's the end of my journey. And so that tends to be the way we think of that, where, you know, I did well, I'm done, I'm moving on. Let's talk about machines a little bit.
Yeah. So revisiting our neural network here. Once that forward pass is done, then you measure, hey, did I get it correct or did I not get it correct? And how much of an error did I make? And that allows you to go back, and it's called the process of back propagation, where you take those errors and can feed them back through the network and update the weights that contributed the most to the error that was seen in the output. So really the whole idea is focusing on the biggest errors that the model is making, so that it can most quickly make the adjustments that need to be made.
So when you think about, you know, what we can take away from that, Nathan, I mean, it's really around kind of the concept is retrospection. It's really getting more retrospective on those knowledge gaps. So not just passing the test and then moving on to the next skill. Again, if our goal is learning and it's not just getting the test right, if our goal is learning, then actually getting retrospective, looking back at what we got wrong and trying to figure out why we got those things wrong, and learning from those failures, if you will, from a knowledge perspective.
That's it. And you know, that whole, again, it's shifting the perspective on testing. You know, we all have views of getting you know, completing a test and the feeling of, hey, I'm done. that class is done. And it's a quite a different practice to go back and say, what did I get right? What did I get wrong on that test, so that I can focus on the gaps that I have. And turns out that actually is a practice of elite athletes, that they will hone in on their, you know, maybe they're good at jump shots, but not so good at layups. So they'll practice their layups. Matt likes my basketball.
Oh my good Lord. That's probably never the case. So now we're getting into sports here for Nathan. That's not a good match here, but but that does have, Michael Jordan's one of the best basketball players, the best basketball player of all time. And he wasn't always great at every aspect of the game. He had weaknesses for sure, but really honed in on those weaknesses, to your point. And so another thought process here on thinking of learning, is it top down or bottom up? And so, you know, for me, you know, if you think about the way we approach things in courses, you know, we don't necessarily, when we're taking a course, we don't necessarily take a broad brush across a lot of different topics. We immediately in a particular topic tend to go down into the details. Before we understand general concepts across a broad scope, we will kind of go way down into the details. And that's true in academic settings. It's true when we go into training. We tend to go into the details and jump all the way down into the details before we get the broader kind of general concepts. And that's something I think about as I approach actually learning something. I do that. And you know, there's some research and whatnot that you'll talk about that, you know, shows that's not necessarily the best way to do it.
That's right. So the idea here with machine learning, when you look into how a lot of these deep learning architectures work and dig into how they're learning, there's a common pattern across really all of them, in that they start with very simple basic patterns. So take for example what we're looking at here, where we're trying to detect do facial recognition or doing face detection. The first thing that is learned are angles, edges, corners, and the nice thing about that is that those are common across, you know, really any image. It's not until you get down into the more specific task level, hey, I want to actually recognize a face, that you start needing to get to that level of detail. So deep learning has had a lot of gains, and we'll talk a little bit more about the concept of transfer learning later, but a lot of gains in being able to leverage kind of a general knowledge that can be shared across different tasks.
So I guess the concept here, Nathan, then is to take and apply that sort of top-down learning principle of starting, you know, really, I guess, starting general and kind of getting into the details. What are some examples of that, though? I mean, that's a little abstract. How do I kind of apply that?
Yeah, so all of us, for any task that you're doing, you actually come with some knowledge of something similar. not it may not be very tightly tied to that concept, but really just to it goes into the concept of whole game learning, where you start by playing the game. So if I'm going to use basketball again, Matt. Whenever we learn basketball, who goes out there and goes, well, first of all, you need to know the measurement of the court, because you need to make sure that you don't step out of bounds. You need to learn what out of bounds is, and then you also need to know why the bumps are this size on the ball. No, you just go out and you start playing the game. You figure out, oh, I'm actually not that great at dribbling. Okay, I'm gonna actually go find the details that I need to play the game. And so that's this whole concept of leave off the details that are unnecessary, and focus on the details that you need for the game. It's one of the things that I see a lot of times when people are trying to get into the field of data science. If you look at people posting on like Quora or Reddit, how do I become a data scientist? A lot of the responses are, well, you need to learn calculus, you need to learn linear algebra, and as soon as you think about that, it's overwhelming. But really, do you need to learn all of calculus? Do you need to learn all of linear algebra? Absolutely not. What you do need is to start with some kind of problem, a high-level problem, and then figure out what do I need to learn in order to solve that. So it's just a different different way to view view the learning in a whole game sort of way.
Yeah, yeah. Well, and in a similar way, you know, we also, not just thinking about it top down, but we also tend to learn subject by subject. And so certainly in an academic environment, we do this all the time. I mean, this is very frequently done, where we'll take our math class, just like you were saying there, in terms of learning data science. I've got to go learn calculus, then I've got to go learn statistics, and then I need to learn computer programming. I need to learn algorithms and all these concepts, but I'm actually not going to bring those together. I'm going to learn each one individually, right? And that's oftentimes how we approach learning. And if I'm going to go take a training course, it's going to be in a specific kind of siloed area, right?
That's right. And this has actually been one of the biggest booms in AI recently is this concept of transfer learning. So like I was mentioning before, with the top down, the first things that are learned are simple basic patterns, and it turns out that those basic patterns are applicable across a wide array of tasks. So if you're trying to classify images of food, and then you want to classify images of cars, that you're able to borrow the learning that you had from the first task and transfer it over to the second task. The concept of the slide that Matt's showing here is within subjects, we tend to do the same thing. We look at a subject in a specific way, and you're tied a lot to your environment in which you learn a topic. A lot of research has been done in how test scores drop in just you leaving the environment in which you learn the subject. And so this concept with the way deep learning is used is it applies a technique called data augmentation, where it looks at the task and the data from a lot of different angles. So you see here, you've got images that are cropped or zoomed, rotated, and that way you're not looking at, hey, here's exactly what a 3 is. It has to be in this orientation. It has to be in this zoom level. But you're able to mix it up a little bit, even within a subject. So both mixing up the topics that you're covering and borrowing the learnings that you've had from one topic to apply to another, but also within a subject, changing your perspective, viewing things from different angles, challenging yourself from different perspectives to more efficiently prepare yourself for those the variances that the actual job is going to throw at you.
Right. Yeah. That makes a lot of sense. So, really, we're talking about don't start from scratch, right? So if you're if you know euchre, you can learn pinochle, because they're transfer learning concepts, right? So I'll go to cards instead of basketball, but you can build on your knowledge of what's that.
But I don't know either one of those.
Well, then you're screwed, I guess. But if you can build on your knowledge of corollary topics, there is a much more efficient way to learn. And so, moving on a little bit to the concept of recall. Oftentimes, in a learning environment or in an academic environment, we're all focused on how much knowledge we can acquire, how much we can read, or how much we're doing lectures and we're going to training courses and consuming from an instructor in the front of the room. And so we're very, very focused on learning to us oftentimes as humans is actually we think of learning as acquiring knowledge, which is listening to a book on Audible or these types of things. It's all about consuming the information and as opposed to recalling the information. And so it's the consumption is what we focus on from a learning perspective. And systems don't treat it that way, right?
No, so one of the methods that's used is dropout, and so this really relates to allowing a little bit of time, a little delay to forget. And so if you look at dropout, what it's doing is actually turning off nodes in a neural network and saying, hey, forget these, and then I'm going to test myself without this information and see if I just learned, if I just memorized the textbook, or if I can actually generalize that knowledge to answer the question. This is really related to the concept of desirable difficulty, where you allow a little bit of forgetting to happen so that you can actively recall. There a lot of research has been done around how we actually retain information is through actively recalling that information. That it sounds impressive, but that we can learn. Cognitive psychologists haven't found a limit to how much information we can actually acquire. The big problem is how much information can you retrieve back out of your memory. The dropout is one. Another one is prioritized experience replay. So the idea here is in taking that recall, is making it more efficient. So don't just go back and recall everything. So the prioritized experience replay is a technique that's used in reinforcement learning. Reinforcement learning is where an agent is not giving any data. They're just trained in an environment, and then they collect data and they go, hey, this was a good action, this was a bad action, and then it learns over time. And then prioritized experience replay is a technique where it can go back and review different moves that it took based on the environment it was in, and go, hey, that was a bad move. I'm going to make this adjustment. The interesting thing here is that the way it's prioritized is based on its biggest errors. So this goes again back to that back propagation, where you're focusing on the adjusting the things, or adjusting your biggest skill gaps is where your most efficient learning's going to happen.
Yeah. So just in summary, if you're thinking about taking these lessons and applying them to learning, then it's really spacing the repetition of those topics, right? So don't learn for a long period of time and continue to move on to the next topic and never revisit those other topics, right? So you need to actually repetitively revisit topics, and that's what commits that knowledge to memory. And that's really the way our brains work.
That's right.
And so, yeah, another one here is the learning environment. And so typically, and this is kind of similar to one we were just talking about, but we tend to, as humans, we tend to learn as if we're in a lab. So we're going to learn that information in a place completely different than where we're actually going to apply it. Whether we're going to go learn it in an academic setting that's extremely different than where we're going to apply it, or if we're going to go to a training class that's going to be out of context for where we're going to apply it, almost like it's in a lab, sort of metaphorically.
So just jumping over to what the machine learning techniques how they address this is a couple of techniques. One is validation, and so taking a set of data, holding it out, and saying, "Hey, this is going to represent the real world, and I'm going to test my model after I train it. I'm going to build up this learning that I have, and then actually assess whether I could actually do the job in real life." And an important concept with that is that your validation set is representative of real life. If it's not, if if you're trying to recommend a movie to someone to watch, and you trained your model on one audience, and it's a very biased audience, then then that's not going to work on a general audience.
Right. Yeah, and then similarly, right, your real world simulations, right?
Exactly. So in self-driving cars, this is exactly what's happening. Is you're actually putting yourself in the scenario to simulate all of the types of tasks that you've got to solve in that scenario. And so this really goes into the importance of making your learning as close to the game as possible, as close to the way it's going to be applied as possible.
Yeah. And so really simulate, I mean, we're trying to then basically simulate the sort of real world environment when we're learning, not just be too academic, not be completely out of context for how you're going to apply that information. So get pretty hands-on, right? Try to make it kind of a real world scenario, when you're actually learning something, which goes back to that whole game learning concept, right?
It does, and it goes into a lot of the study has been done in athletics, and they've shown that there are some teams that practice, maybe in hockey they're practicing just one shot from one angle over and over, whereas that there's a lot of actually more learning that happens in kind of a scrimmage, where you're actually playing a fake real game, a simulated game. I think it was Vince Lombardi who said, "Practice like you play, and you'll play like you practice." And so if you're practicing in that lab, that's how it's that's how you're gonna end up playing.
I thought you were going to start pulling out Allen Iverson quotes here, Nathan, about practice, for those of us who liked Allen Iverson. But so key takeaways on how we can learn better as humans, really reflecting on practices and techniques from machine learning. So remember, the machine learning techniques actually came from how we best learn as humans. We've for some reason have not 80 years later really still incorporated these into how we learn. And so test early and often. Don't think of tests as such a bad thing. Think of those as part of the learning journey, not just part of the measure of learning. It's actually part of learning in and of itself. And get retrospective on knowledge gaps. And so after the end all be all isn't the assessment at the end of learning something. It should actually be taking that information and understanding where the weaknesses are, and then going back and revisiting that and leveraging that to really learn more effectively. We talked about applying top-down learning principles as opposed to jumping right into the details. Understand the concepts and make sure you understand those patterns across a broader array of things before you jump way down into the details. And then the next one, what that allows you to do is it allows you to build on knowledge of those patterns. So to start actually building on the knowledge from corollary topics and really building on those patterns that you understand. I mean, you may not know euchre, but if you did know euchre, it actually will help you learn how to play pinochle. And then, we talked about spacing exposure to topics, of spaced repetition, making sure that you don't just kind of move on to other topics and not revisit this. In our sales processes, because we apply these principles to our product at QuantHub, a lot of times I say the best training course I've ever gone to, unfortunately, I can't remember a thing from it, because it was at MIT. It was this amazing course. And so I learned it in this immersive environment, completely out of context for where I would use it. And it wasn't super hands-on. And then I actually didn't have any spaced repetition of those concepts. So I learned it and I didn't use it right away, and then I forgot it all. And so there was this amazing training, and it just never actually proved to be very valuable, because a lot of these concepts weren't really applied. And then the last thing you talked about, Nathan, was get hands-on, not to be in sort of a lab environment, but like practice like you play. So get out there and actually, I mean, you need to hone your techniques in specific areas, and there's a time and place for that. But if that's all you do, then it's going to be difficult to, or it's not as effective as if you actually learn it in a sort of simulated game environment, right?
Right.
So just real quick, what we think about at QuantHub, and I'm not going to talk about what we do, but I'm going to talk about how we implement this, because I think this framework can be useful when you think about your own learning. So this is how our product works from a learning data perspective, but it applies more broadly. Is that the first thing that to do is start figuring out where your skills are. There are so many assessment products out there, whether it's the data ones like us, or there are just all kinds of products out there that can help you routinely incorporate assessments into your learning process. And so start with a test. Remember, one of the things we talked about earlier is a test first approach to learning. So not having that anxiety around testing, but really realizing that it is invaluable information for learning. So determine where your strengths are, determine where your gaps are. If you can, benchmark those against other groups to help, again, hone in on what areas of strength you have and what areas of opportunity exist in sort of your skills. And then that allows you to really now start finding those learning opportunities. We have a learning recommendation engine that is based on those assessments. So based on the results of those assessments, we can actually recommend different types of learnings, but you can do this as an individual as well, of doing these assessments, figuring out where those gaps are, and then just start doing Google searches for lighter weight things. It can be blog posts, Reddit threads, Stack Overflow posts if it's a technology type thing. And you can really start trying to find those opportunities once you know exactly where you need to focus. And then learning from those things, but actually learning those in a more of a spaced repetition manner. So if you're going to learn them once, if you're going to consume content, make sure that you don't just forget it and learn it when you're about ready to apply it. And so that'll give you a chance actually of, once you apply it, then that'll give you a much better chance of retaining that information. Nathan, talk a little bit about, I guess maybe we'll close on this, but one of the interesting things that I think we've thought about is that we tend to learn really, really effectively on the job, right? We always know that we go to college or whatever, and then we come out of college and we say, I don't feel like I learned as well. And then we get on the job and we're immersed in all this stuff we don't know, and we learn it really, really efficiently. Talk about that briefly, like why, how is that applicable to what we've been talking about?
Yeah, so that's a good question. With the on-the-job training, again, it kind of forces a lot of these practices without you having to think about that you're doing them. So you developers out there, coders out there, whenever you run into something you don't know, how do you learn it? just go look at, go Google it, go check Stack Overflow. You know, so you are constantly being assessed by the task that the job throws at you. You're being benchmarked against, hey, here's what your job description said you should be, or where your peers are, and you're finding the learning opportunities and actually learning, and then as they come up again, that's how they these concepts get actually acquired and managed. The challenge still with on the job learning is that it's not a formal process, and so there is a bit of you can lose some of the things that you I jumped from this project to another project, and I wish I still remembered how to do X from the other project, but I didn't maintain it. And so there's some relearning that happens. So there's a lot of benefit, I think, in the relearning. Really, Matt, I think it comes down to what Christina pointed out. She said she was learning French, and that immersion. So it's all about the immersion. So getting in there and having your assessments even look real world.
Agreed. I think a lot of, I mean, and actually, a lot of the language learning platforms implement these types of techniques. A lot of the ones you hear about on radio ads and that type of thing, they implement these techniques because it's typically people need to learn languages and they want to learn quickly and be able to recall that when they need it, if they're going on a vacation or whatever. And these techniques are the way to do it. And you could see they're just implemented throughout those platforms. So that's it from us. Thanks for having us, Dion, Christina, Rebecca. We appreciate it. It's been fun being here. We enjoy these weekly sessions, and thought it'd be fun to get on here and talk about how we learn and you know, kind of what we can get from our Terminator cyborg friends.
Yes. Thank you all so much. This was great. And I've written down, let's see, 4 pages of notes. I was like frantic. I'm like, I hope he lets us use these slides. This is great. You know, the first thing that I thought when you were going through this is that it seems that what we know in child development and educational philosophies and how the brain works, what is shocking to me is our education system seems very antiquated, you know, where it's subject by subject and there's very little crossover. And I think something that you had said, like finally hit home to me. There was when I was in high school, there was a semester or a year that I had to take chemistry and algebra 2 at the same time. And math was never a strong suit for me, but I think it was because of being forced to take chemistry, and you have to have a knowledge of, you know, algebra 2 in order to do chemistry. It forced me to actually finally, you know, memorize those equations and understand why those equations work. You know, where I struggled because of the application piece. Now I'm taking a class where it's very obvious how these, you know, this knowledge is applied. And so, you know, with that said, I think our education process, you know, there's very few areas in which we are training the future generations to actually behave like they are future, you know, doing jobs of the future, right? The jobs that they are training for. I mean, when you are studying computer science, for example, at a university, you're not doing it in a, you know, in an office environment where that's where you learn a lot of actually what you will be doing, but you learn it in a lecture hall where you're learning the theory of computer science, and then you have a lab where, you know, you're all in rows and you're typing, and that's not what the real world looks like. And so I think this would be interesting if you guys could take this and provide this to educators, you know, and get, I guess, more buy-in from the people who are developing these curriculums and whatnot.
Yeah.
I'm sorry, that was
What's
just a big soliloquy.
Yeah. Well, I mean, it's interesting, Christina, in some of the programs at Tech Birmingham on the, you know, the kids coding, the girls who code type programs,
Yes.
you know, those are much more immersive, or those are much
Yes.
more practice like you play type programs, right?
Yes.
I mean, they're getting, and they're just jumping in and starting to write code
Yes.
and create things. And so it actually is more aligned with this type of approach to learning than the more academic setting.
Yes.
But actually can be much more effective in that way. And it doesn't mean that some of the things that you learn in academia are irrelevant. It's just that it's a different way of learning some of those concepts. And in fact, someone, Jennifer, asked a question, with tech and AI, et cetera, constantly changing, are there foundational components a person has to retain and, you know, that they need? And, you know, there definitely are. I mean, Nathan can speak to those. They definitely are. It's just the thing maybe that's a takeaway from here is, how do you learn those things? Mm-hmm. It's not necessarily by taking a big, long set of statistics courses. It doesn't have to be anyway. Big, long set of other mathematics courses, big, long set of IT courses in programming. It doesn't have to be done that way. But Nathan, you can actually answer the specific question, just kind of some of the foundational components though.
Yeah, I mean, I'm guessing the question is more geared towards the skills, the different skills that are required as the foundational. I'd say that the one that relates more to this talk is just problem solving, and being able to draw on all of your experience to solve a problem. Like all of your experience, all the tools at hand, and because over time, as you solve more problems, you build up more ways to solve those. And so, of course, the tools out there, whether you're using Python, R, SAS, SQL, whatever, those change. The data that's available, that changes. The methodologies that are required to pre-process that data, you know, they may get automated. Same with machine learning, deep learning. The main thread throughout that is leveraging the things that you have, having the awareness of what tools are out there to actually solve the problem you're trying to solve.
Yeah. Nathan, there's another question on were these principles discovered in human cognitive studies first, then applied to AI, then brought back to human learning theory? Certainly timeline perspective, that was true, right? It was actually in the 30s when some of this cognitive psychology research came about, right?
That was it. You know, it's been an interesting journey because these fields kind of developed in parallel, and you're like, certainly they're influenced, but they don't reference each other a whole lot. And so it probably depends on who you talk to. If you talk to a cognitive psychologist, they say, yes, it all came from us. Where the more machine learning world would say, no, we just decided to model this off of the human brain. But in doing so, that's a clear that is a clear tie to that. Hey, we made a conscious decision that we were going to model this off of the human brain, how we teach computers to learn, and therefore we need to do our research on how do humans learn.
Nathan, I'm going to jump in. Well, first, Matt, and you, Nathan, I don't think I've ever heard so many references to basketball and cards. So maybe the fact that Allen Iverson's initial is AI, we're talking about AI, maybe something was going, yeah. Something
There you
was
go. It didn't even dawn on me.
We talking about practice?
Yeah, we talking about practice.
One of the greatest quotes of all time for those who
All
have
time.
question marks over their heads. I was struck by a couple of things. One was I believe it was embracing difficulty. I can't recall the exact phrase. Desired difficulty. We actually kind of when we're going through the whole Ed Farm process, embrace the idea of productive struggle. And just really adopting that mindset was quite impactful and powerful. I mean, there was another thing that I wanted you all to take on just quickly to respect everyone's time. How do you create or foster that culture, that environment where you can get that on-the-job training, really in the literal sense, where your team and your colleagues do not feel as if they will break something, right? I'm going to get in trouble for this. I don't want to do it. I want to play it safe. How do you foster that environment where you can get out there and try your hand at it and learn like that?
Yeah. So it's a great question, Dion. I'll actually go to Agile software development. This is a similar problem of how do you actually release often, and the way you do that is you have to actually minimize the impact of what you're doing and do it in smaller pieces, so that no one thing has as much of an impact, so that you can do it frequently. In this learning context, then to get past that culture of where there's such a fear of failure in those assessments, then do it often. It's like Nathan said, we talked about sort of test first. And so the way we implement that is, this is like a daily thing actually, and it's meant to be like 5 minutes. So we're recommending blog posts, we're recommending towards data science articles, we're recommending Reddit threads, and these things are like 5 minutes to consume them. And then we pair assessment questions with them. It's an active learning technique called a digital scavenger hunt. And so you're trying to answer these questions by reading this article. And so in doing so, it actually then starts removing the fear of failure and starts instilling a different aspect to the culture where it's about continuous learning and assessments just being a part of that, as opposed to ingrained in our minds, assessments are tests and we are graded on those, pass, fail, and my future depends on it. It is a cultural shift to get away from that and to have assessments be baked into an everyday type of thing, and doing it in bite-sized chunks is what helps make that happen.
Awesome. Thank you.
So, Matt, one thing that, as you were saying that, even the whole way that we are testing, the focus of our test is, the test is the end all. And, right. rather than look at, okay, well, you got 96% correct. What about that other 4%? You still haven't had a whole, you still haven't had 100%. So rather than us, go back and look and assess, well, what of that 4% can we bump up to increase? We usually, our philosophy is like, well, that's good enough. Let's just move on. So I think this, for like a company, companies can't afford to have those types of errors, obviously. And so in the real world, you go and you look and you find where those errors are and you try to fix them. So again, like in learning, I think we need to adopt that approach that, there still is more to learn even after we've done our assessments.
Yeah, it goes away from being a check the box thing where I completed this to it's now a journey of learning, right? Yes. It's a continuous journey, and I'm always iterating on that. as opposed to I check the box and now I'm done learning. I've
Yes.
learned that thing and I went to that training. I'm all good.
Yes,
Not
exactly.
what it's about, right?
No, it isn't. So, well, thank you. I know we've gone over, so I thank everybody for being with us today. Thank you, Matt and Nathan. This was extremely educational, and I think there's a lot to think about and unpack, and I hope that those who are on the call will be able to have a lot of really good takeaways and apply this to their businesses and their personal day-to-day lives. I think I might have to look at some of the other language apps that instead of writing out my flashcards like I used to in high school, I'll have to look at a more immersive program so that I can learn French. And I have no purpose to learn French, but just because I want to. So,
Yeah. Okay.
Well, thank you.
Thank you
Dion,
so
do you want
much.
to close us out?
Thanks, everyone.
No, I think that's perfect. We have fully discussed artificial intelligence and Allen Iverson. If you do not see the benefit of joining us on these discussions now, I don't know what will. But again, thank you, Nathan, Matt, really appreciate it. Thank you to everybody who joined us, and we will catch you again on the next series. Have a good one.
Bye.
Thanks,
so much.
everyone. Bye. Thanks.